Morning to my committee members, Dr. Emily King and Dr. Cesar Marquez Chin, as well as to my external reviewer, Dr. Shiros Khan, and welcome to my presentation on the design and evaluation of a hand hygiene prompting system for the use in private residences. Our presentation will go as follows. First, I'll present a background on the importance of hand hygiene and existing methods that we use to improve hand hygiene adherence, methods that we used in system design and to evaluate our system in improving hand hygiene adherence, results that we collected through data collection points, as well as some discussion points, conclusion, and if time allows, some future work. So as we're all aware, hand hygiene is extremely important in preventing the spread of infection, has been well documented in clinical settings. But there's been limited focus within the home environment with regards to quantifying hand hygiene adherence rates, as well as methods to improve these. From the limited literature that we found it to be as low as 36% in some instances. But why is this the case? Hand hygiene is such a simple, easy behavior to learn, but it is often overlooked and undervalued, as individuals in the community only see it as being beneficial when their hands are visibly dirty or soiled. But within the clinical environment, this is well understood and its importance is well known. So we've created several technological solutions to try and aid in improving hand hygiene adherence rates. And these usually include real-time location systems and RFID tag systems, which essentially work by tracking the real-time location of healthcare workers and prompting them to wash their hands if it detects the opportunity has arisen. We aim to do something similar, but within the home environment itself. And we can summarize this in several primary and secondary objectives. The first being to develop a hand hygiene prompting system that can be used at the entryways of private residences. Once this system is developed, we then aim to evaluate the changes that it has on hand hygiene first during a prompting period, and whether there's any sustained adherence when prompting is deactivated within our study. What we hypothesize is that once prompting is used, we'll see an associated increase in hand hygiene adherence and then associated decrease when prompting is deactivated, but we don't believe it will return to a baseline measurement, which we make in our study. We also want to evaluate the changes that our device has after the system has been installed. So we'll be comparing this to the results in a pre-study period where participants record how often they're washing their hands, and we want to see whether it's significantly different once it's installed. And what we hypothesize is that there will be an increase in hand hygiene adherence. We also want to determine if there's a relationship with the reaction time during our 180-second prompting period. And what we hypothesize here is that individuals will be far more likely to interact with the device immediately after the first prompt. We also want to determine how we can improve the systems through the distribution of a final survey. Now let's dive right into the methods, and we'll first summarize how we design the system, then move into the detection and classification accuracy of the system, and our main portion of our project, which is the hand hygiene adherence study. But first, let's dive into system design. Our main design challenge was to design a device that's able to detect individuals entering or leaving the home. But we wanted to do this without the use of cameras, as it is in private residence settings, and without using cameras, this promotes privacy within the home. This can be easily achieved through the use of two passive infrared motion sensors, which measure the infrared radiation in the background and produces an associated voltage output dependent on the amount of infrared radiation it observes. We also have an LED and a buzzer inside a device that prompts individuals to wash their hands if it is detected that they've entered without doing so. It is battery powered, and there's an alcohol gel dispenser built into the device itself. The heart of the device is the classification system, which aids the device in determining how individuals are moving through its field of view. Ultimately, we chose to use a decision tree model on our device. The classification system extracts features from the analog output of our motion sensors, and the waveform produced by the motion sensors is completely unique to the type of waveform it's being absorbed, type of movement it's being observed. That is, a left-moving individual will have a distinctly different pattern than a right-moving individual. Depending on the movement event that has been classified, our system will respond accordingly. If it sees that someone has entered the home, it will prompt them to wash their hands if they haven't done so. But if it sees that they're leaving or just moving around through its field of view, it will do nothing. Here's an example of the system installed at the entryway of my home. And now just a quick demonstration of how the system itself operates. You can see here, as I'm entering my very messy apartment, the system then detects that I've entered my home, and it prompts me to come back to it as it is seen that I've walked past it without interacting with it. It then begins its prompting cycle as it has determined that I've entered the home without washing my hands. We move on to the detection and classification portions of our study. First being the classification accuracy study, where we recruited participants to perform a predefined set of movements, moving from left to right, right quadrantial movement, moving from right to left, and left quadrantial movement. In the same time, we have our device turned on, recording these movement events through its field of view, applying classified labels to it. We'll take these ground truth labels that are in our predefined set of movements and compare it to the movement events that are classified by our device, determining the classification accuracy of our device. And this will be determined through a simple confusion matrix. We also want to determine how well the device detects the movement of pets. And we made the design choice to restrict the vertical field of view of this device to emit any IR radiation emitted by warm bodies on the lower focal plane of our device. This way, we hope to avoid any movement events that are triggered by pets, as this may affect the results of our study. And the way we did this is that we used an unmodified and a modified Fresnel lens and compared the output of both of them. We required an individual to linearly move through the field of view of the device, triggering a movement event. We then had a pet follow, and we wanted to first see whether the device detected the pet moving through it, and if it did detect that they moved through it, whether it was a linear movement event, so right to left or left to right, or a quadrantal movement event. We consider the detection rejection accurate if it detects a quadrantal movement event, as this will not trigger a hand hygiene opportunity, or if it omits the detection at all of the pet. We will consider a failure if it detects the same linear event that was produced by the ground truth label from the individual. And just to note, this is how we modified the Fresnel lens in our case. We can see here that we've blacked out the bottom portion of our device. We blacked out the bottom portion of our device to omit any IR radiation that is absorbed through that area. And now is the main portion of our study, which is the hand hygiene adherence study. Our hand hygiene adherence study is a 4-week monitoring study with a pre-monitoring period and a monitoring period with associated surveys at different portions throughout the study. We recorded 20 participating households and split them into a control and intervention with 10 households in each group. Our first data collection point is the pre-study survey, where we asked associated questions measured on a visual analog scale regarding how important individuals believe hand hygiene is in preventing the spread of infection, as well as questions regarding how they believe the provision of a prompting device will affect their hand hygiene adherence. We would then move into the pre-monitoring period, where we distribute the week 0 self-reported adherence survey, where individuals in our study will report how many times they left and returned home, and of those instances, how many times they washed their hands over the entire course of the 1-week pre-monitoring period. Our monitoring period then begins after this once the system is installed, and will continuously monitor hand hygiene adherence rates over the 3-week monitoring period. Where in the control group, they will not have prompts used at any time, but in the intervention groups, prompts will be employed during the 2nd week. We'll use a mixed ANOVA model to evaluate the differences in between subject factors adherence, which is the adherence between groups, whether there's a dependence on time with the adherence, so that within subject factors, and whether there's an interaction effect present. So does the adherence rate measurement depend on the time and group that that measurement was taken on? Our last data collection point will then be the final survey, where we collect information regarding how individuals would change the system design and how they felt the provision of the reminder device improved their hand hygiene adherence rates. Let's move on to some of the results and discussions that we captured through our various studies. The first being the detection and classification accuracy study. In the classification accuracy study, we recruited 4 participants, 2 males, 2 females, with ages ranging from 24 to 61 years, heights ranging from 149 centimeters to 176, and weights ranging from 58 to 86 kilograms. In our classification accuracy study, our system captured 104 movement events. Of those 104 movement events, 103 were classified correctly, with one of the linear movement events being right was classified as a quadrantal movement event as no right. But this indicates to us that our system is highly accurate in determining the direction of motion of individuals through its field of view moving in and out of the home. So then we can confidently say that the hand hygiene opportunities that our system detects are likely truly hand hygiene opportunities. The next portion is our pet detection study, where we were only able to recruit 1 medium-sized dog with a weight of around 18 kilograms. And we performed movement events across the unmodified and modified lens case, 14 movement events in each case in total. Within the unmodified case, where the field of view is not restricted, we see that the device is able to capture 13 different movement events, with 11 of those being linear or failures, and 2 of those being quadrantal movements, giving us a final rejected plus quadrantal movement event rate, percentage of 21.43%. In the modified lens case, where we restrict the bottom field of view of the device, we see that only 3 events were captured, where one of those was being a linear movement event, and 2 of those were being a quadrantal movement event, giving us a final rejected plus quadrantal ratio of 92.86%, indicating to us that if a medium-sized dog is present, that our system does a fairly good job in rejecting its movement. One caveat that we should consider with these results, though, is that we're only able to test this on one medium-sized dog. So if a large-sized animal or a small-sized animal was present in the home, we do not truly know the effects that it will have on our results. What we can say that is that it probably does not reject them as well in the case of a large animal. Our hand hygiene adherence study and the results captured from this is the main portion of this project. We recruited 27 participants across the control and intervention group, with 13 in the control and 14 in the intervention, with the distribution of sexes across the control and intervention group being quite similar. We attempted to counterbalance these two groups by balancing the amount of homes that have pets present and children present, where we're able to achieve 4 homes in the control and intervention with pets present and 1 home within the control and intervention with children present. The age and education distributions of our participants are fairly similar across groups. Our first major data collection point occurred in the pre-study survey, which was right before the pre-monitoring period. The pre-study survey had 5 visual analog scale scored questions that we asked. And we can see immediately from the figure on the right, which outlines the questions along the x-axis and the visual analog scale score along the y-axis, that participants are answering these questions generally to the same degree. Where in the first question, we asked how important they believe hand hygiene is in preventing the spread of infection, where they all kind of generally approve that it is important. Within the second question, we asked with regards to how motivated these individuals are. And again, we see across the control and intervention group that they are generally the same level of motivation, with some being unmotivated, but most of them being motivated. Question 3 showed the largest difference in the distributions, although when using a student's t-test, we found that these differences were not significant. But what we can generally conclude from this is that individuals in the intervention group look to be perceiving themselves to wash their hands at a lesser frequency than that of the control group. Question 4 asks with regards to how they believe the provision of gel alcohol will improve their hand hygiene adherence. And again, we can see that they generally agree across groups. The last question is with regards to how they believe the provision of a reminder device is. And we can see again here that most participants within the intervention control group agree that it will have a pretty big impact on improving their hand hygiene adherence. Our pre-monitoring period had the distribution of the week 0 survey, where we asked participants to self-report their hand hygiene adherences within that survey. And then we compared those results to our monitoring week 1 period to determine whether there's any significant difference in adherence after the system has been installed, which is during monitoring week 1. And what we can see from these results here is that these distributions are not significantly different. So it looks to be that individuals aren't changing their hand hygiene habits when the system is installed. We dove a bit further here in expanding the week 0 self-reported rate across the x-axis and regressing it against the monitoring week 1 adherence rate captured during our baseline period. And what we can generally pull from this data here is that individuals in the week 0 self-reported survey seem to be inflating their hand hygiene adherence rates, where they're reporting higher rates than was captured during our monitoring period. There are several reasons that this could be possible. The first being a phenomenon known as the Hawthorne effect, which has a much greater impact on self-reported surveys as opposed to external electronic monitoring, where individuals might be inflating the results that they report because they know they're being monitored through that survey. And the second being that participants during the week 0 self-reported period only responded on that survey, where there was no one who wasn't participating in our experiment that weren't responding on that survey. Whereas within monitoring week 1, we may have had people entering or leaving the home that weren't actually participating in our survey, as well as pets maybe triggering some movement events, which could be conflating the results. We then move on to the monitoring period, which is our 3-week monitoring period. We have the monitoring period here outlined along the x-axis and the adherence rate associated with our measurements outlined here along the y-axis. We measured the adherence rate across the 3-week monitoring period in the control group, which is outlined here by the dashed gray line, and the intervention group outlined here by the light gray line. And what we can generally see from this figure here is that in weeks 1 and 3, the adherence rates between the control and intervention group have very little difference between each other. And in fact, these results aren't significant. But if we look at monitoring week 2, we do see a very big discrepancy between the control and the intervention group, where the intervention group on average was washing their hands at 64.3% more opportunities than that of individuals in the control group. To concretely quantify this, we deployed our mix of ANOVA model, comparing whether there's a significant difference in adherence rates between subject factors group, which we in fact found, whether there's a significant dependence on time with adherence rate, and we found this as well, and whether there is a significant interaction effect between the group and time. So was the measurement dependent on what group it came from, as well as the time of the measurement? And we found that this was significant. This would indicate to us that then there is a main effective time that we need to dive further into the data to find. We then deployed one-way ANOVAs as our first step in post hoc analysis across the control and intervention group to determine whether these groups show a significant relationship with time and adherence. And this was found within the intervention group. We took this a step further by using Tukey's means difference test to compare the adherence rates across weeks in the intervention group. We first compared the adherence rates from weeks 1 and 2, weeks 1 and 3, and then weeks 2 and 3 to see whether there's any significant difference. And what we found is that there is a significant difference in adherence between weeks 1 and 2 and 2 and 3, which would indicate to us that the main effective time is in fact occurring in week 2, which is our prompting period. One important thing to note too, though, is that we did not find a significant difference between weeks 1 and 3. So we did not see any sustained adherence after prompting was deactivated during our 3rd week. One thing that we have to consider is that although hand hygiene is a simple behavior to learn, what we were aiming here was to see whether there's any behavior to learn, any behavior being learned. And from the 1 week prompting period, as we know from habitual learning, that even a 1 week period to try to change different behaviors is likely not enough, even if this behavior is simple. So in future steps, we should maybe consider a longer study to observe sustained adherence. We then looked at the reaction time across the groups, where we measured the reaction time as the time it took for individuals to come back and interact with the device after it has immediately determined that they've returned home. The difference is that within the intervention group, individuals receive a prompt to go back to the device, where no such prompt exists within the control group. And we can see immediately from the figure on the left, which is the distribution of reaction times in the intervention group, compared to the distributions of reaction times with the control group, they're starkly different, where individuals in the intervention group are far more likely to go back and interact with the device. If we take this a step further, observing the distribution and overlaying the times where prompts were elicited, we can see that the reaction time distribution in the intervention group follows more of an exponential decay. And there is some visual alignment with when prompts were used and some spikes in the reaction times, indicating to us that individuals in the intervention group are being prompted to use the device. We do not see such exponential decay in the control group. This distribution looks far more uniform than exponential, and we can see that individuals aren't going back to interact with the device as often. Our last data collection point is through our final survey, which was distributed to each participant after the conclusion of our monitoring period. We can draw several conclusions from this survey. The first being that the control participants reported that they found that the device or the provision of an alcohol gel dispenser had very little effect in improving their hand hygiene adherence results. And we could see this across the distribution of control group responses, where we see that there's a slight difference when comparing weeks 1 to 2, but it generally does not change when comparing weeks 2 to 3. So we can see it's having no impact on their hand hygiene adherence rates. The converse is true with the intervention group, where the intervention group reported that they found that the device was very effective in improving their hand hygiene adherence rates. And again, this is quite obvious through the distribution of adherence rates, which we captured, where there is a large spike in week 2 when prompting is activated. Our last conclusion that we can draw from this data is that 6 of 10 intervention participants reported that they found the device became annoying during the prompting cycle. So if they were to make one design change, they would change how the prompting is delivered, as well as possibly the prompting cycle itself. What can we conclude from this project? Well, the first being is that we were able to successfully design and test a prompting device for the use of private residences. We saw that when we tested this prompting device in our convenient sample of 20 households, that it resulted in an increase in hand hygiene adherence when the prompting was initiated, but we did not see sustained adherence when prompting was deactivated, which is something that we aim to achieve in the future. We saw no significant difference in adherence when we compared the self-reported rates to the baseline monitoring period rate, which was captured in monitoring week 1. But we did see a relationship with the reaction time during our prompting cycle, where individuals were far more likely to interact with the device after the first initial prompt. We also then think that our first design iteration should involve the changing or a modification of our prompting scheme, as many participants within the intervention group outlined that they found this became annoying over time. Due to our time constraint, we could leave the discussion of future work to our discussion after this presentation, but we should focus on 3 main topics, the first being long-term adherence, the modification of the prompting scheme, and design improvements to make the design more easy or usable by our participants. Thank you for listening to my presentation, and I'm happy to